Hi class, this is section 1.4, which is on quadratic equations. So we're going to solve this quadratic equation by factoring. We can tell it's quadratic because of the x squared term. That's what makes it quadratic. So in order to solve, we first need to factor the trinomial. So this is the way I like to factor trinomials. I draw a little x or a diamond. A times c goes up here, b goes up down there. A in this case is 1, B is negative 10, and C is 16. So A times C would be 16, and B is negative 10. Then we need to find two numbers whose product is 16 and whose sum is negative 10. So I believe it's going to be negative 8 and negative 2. If you multiply these two numbers together, you get 16, and if you add them, you get negative 10. Because the leading coefficient is 1, that means we simply have to just put these numbers in parentheses in our binomials. X squared becomes x times x, and negative 8 times negative 2 becomes positive 16. All right, and now in order to solve, we have to set each of these factors equal to 0. That's called the zero factor property. And then we solve each of those individual equations. So x equals 8 and positive 2. So 8, 2 would be our final answer. So now we have a similar problem, but this time the leading coefficient is not 1, it is 5. So we can do it the same way. So A times C is negative 40 this time, and B is negative 39. Now, the two numbers that are going to make this work would be 40 times 1, but we need the 40 to be a negative. Then you want to take the middle term and look at the variable. The variable is x. Therefore, we put an x here and here. And now we're going to just rewrite this trinomial, and we're going to convert it into a polynomial with 4 terms. So the first term stays the same. The second term, this breaks up into these two separate terms that we came up with. Negative 40x and positive 1x. And then minus 8 remains there. So now we're going to factor by grouping. Grouping is when you group the first two terms together and you take out the GCF. The GCF here is 5x, which means divide it out. So if you divide it out, you're going to be left with x minus 8. Then over here, notice that this is already identical to what we need. So there is no common factor. So we're just going to divide by 1 because there's nothing to take out. So you do need to put this plus 1 here. You need a placeholder. And now you're going to just write x minus 8 because that's what happens when you divide by 1. Now you have a common factor of x minus 8. That comes out to the front. You divide it out. That's your new GCF. And finally, you're left with 5x plus 1 equals 0. Zero factor property says we must set each of these individual factors equal to 0. So this one's going to be x equals 8. This one's going to be negative 1/5 if you solve for x. So that would be our final answer for that problem. All right, moving along. Now we want to solve by completing the square. The reason they say that is because you're not going to be able to factor that trinomial even if you try. It's not factorable, so that's why we have to resort to a different method. So these are the steps to completing the square. Step 1 would be to make sure that the leading coefficient is 1, which it is. There's a 1 there, so we don't have to do anything special. Normally you would divide out that coefficient, but if it's 1, you don't need to. So in this case, we're going to go with step 1 is to bring the c term over. So let's move the c term over. Move c term over. So if we do that, we're going to get plus 2 plus 2. So far we have x squared plus 8x. I'm going to leave a blank here, equals 2. So here in this blank, that's where step 2 comes in. I'm going to call it complete, find the missing term. So this missing term, the way you get that missing term is by you divide the b term by 2. So I'll write that formula out. So it's going to be b divided by 2 squared. That's what goes in the blank. So b for us is 8 over 2 squared is 4 squared, which is 16. So we're going to add 16 to both sides of the equation. Try not to forget to add it to both sides. All right, that would be step 2. Step 3 is to factor the trinomial, factor the perfect square trinomial. So this trinomial will always be a perfect square. So if you factor it, you're going to get x times x, and 4 times 4 gives you 16 and also adds up to 8. So it's plus 4 plus 4. So that's what we mean by a perfect square trinomial. You're going to get the same factor two times. And on the right side, we have 16 plus 2, which is 18. And we want to rewrite this with a square exponent. And the reason we want to do it that way is so that we can get rid of that by taking the square root of both sides. So they cancel. And you end up with x plus 4 equals, you always get plus minus when you take the square root of an equation. And 18 becomes, that is 9 times 2. But 9, the square root of 9 becomes 3. So we end up with 3 square root of 2. And the final step is to solve for x, and we do that by subtracting 4. So our final answer is going to be x equals, you always want to write this term before you write this term because you want the plus minus to be in between the two numbers. So we're going to write negative 4 first, and then the plus minus 3 radical 2. WebAssign is going to want you to separate those two answers, split them up, separate the plus from the minus. So you would want to enter it this way: negative 4 plus 3 radical 2, comma, negative 4 minus 3 radical 2. So that's how we would enter our solution. All right, this next problem is the same directions, completing the square. So let's go ahead. The leading coefficient is 1, so we don't have to worry about dividing by the leading coefficient. Step 2 is to move the c term over. So we'll do that by subtraction of 29. So we get x squared plus 30x. Remember to leave a space there, equals negative 29, because we need to find the missing term. So remember, the way we do that is we take our b term divided by 2 and square it. So b is 30 divided by 2 squared is 15 squared, which is 225, I believe. Yes, 225. So that is what we add to both sides of the equation. And then we need to factor the trinomial. That's the next step. So we know it's going to be a perfect square trinomial. And on the right side, we combine those, which I believe will be 196, I believe. Yes, 196. So here is going to be x times x. And then we have to figure out what number times what gives us 225. Well, it's 15 times 15. You just have to make sure that they add up to the middle term, which they do. So positive 15, positive 15. Then we want to rewrite this as a perfect square binomial. Take the square root of both sides. You end up with x plus 15 equals plus or minus. This is a perfect square. It is going to be 13, I believe, or 14, sorry, 14. And then our final step is to subtract 15. Remember, we want to write this number before we rewrite that number. So this would become x equals negative 15 plus or minus 14. So now we have no radicals, we have like terms, so we can separate the the plus and the minus. Let's do the addition first. Negative 15 plus 14 equals negative 1, comma. Now we can do the subtraction. Negative 15 minus 14 is negative 29. That is our final solution. All right, now the directions say find all real solutions of the equation. So we have some options. We can try factoring, or we can try completing the square. I would recommend the quadratic formula because the numbers are a little big and it gets a little complicated if you're trying to complete the square with the fraction. If you divide by 3, you end up with a fraction. So I would recommend the quadratic formula, which says that x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. We already know that the coefficients are 3 for a, 19 for b, 16 for c. So now it's just a matter of plugging in these values into the quadratic formula. So negative 19 plus or minus 19 squared minus 4 times 3 times 16, all divided that by 2 times 3. This is going to be 19 squared minus 4 times 3 times 16 is 169 over 6. And the square root of 169 is 13. So we get negative 19 plus or minus 13 over 6. Now this is where we can split it up into two separate problems. Negative 19 plus 13 over 6. And negative 19 minus 13 over 6. This first one's going to be negative 6 over 6, which is negative 1. And the second one's going to be negative 32 over 6, which simplifies to, well, we can divide by 2. That's going to be 3 in the denominator and 16 in the numerator. So negative 16 thirds. So our final answer would be negative 1, comma, negative 16 thirds. The last problem is the same directions, except now we have fractions. In order to get rid of the fractions, you can multiply through each term of the equation, or multiply both sides of the equation by the lowest common denominator, which happens to be 9 in this case. So multiply both sides of the equation by 9, that's your LCD, and then distribute. So if we do that, we're going to get 9x squared. When you distribute here, the 3 goes into the 9 3 times, so you get 30x minus 30x. And here, the 9's cancel out completely. You're just left with 25 equals 0. At this point, we can either do the quadratic formula or you can try to factor. Notice that this is a perfect square and this is a perfect square. Usually when you have two perfect squares, you could factor this most likely. So what I would try was I would try to break this up into 3x times 3x. I would break this up into 5 times 5. And then you would want to check the inner and the outer terms to see if it adds up to negative 30. So that's 15x and 15x. If you make these negatives, then you're going to get negative 15x, which is negative 30x, and that would make it work. All right, so that's going to do it. Now we set them equal to 0. Since they're the same factors, you only need to set one of them equal to 0. You don't need to set both of them equal to 0. And then you would solve that equation. So that would be our final solution, 5/3. And that concludes this section.